Hey there, welcome to Theoretics, where we make your high school life simple. I'm Aniket, and in this video, we're going to do a super fast regression using DESMOS, and we'll be solving some of the tough SAT math questions. I just want to show you how to do any kind of regression, any function that is included on the SAT math syllabus in under 10-15 seconds. Okay, so let's begin. Okay, so we'll first pick a question that is a hard difficulty question, mostly on the module 2 of the SAT math. Okay, and let's see if it can be done really well and quick with DESMOS instead of doing manually. Okay, so here's a question. The XY values are given, okay, and it's saying the table shows 3 values of X and their corresponding values of Y, where Y is equal to f of X plus 4 and f is a quadratic function. What is the Y coordinate of the Y intercept of the graph of y is equal to fx in the xy plane? So they've given these values for fx plus 4. So how do we convert them into fx? Do that quickly. Y, so this will become negative 12 because negative minus 4, 8 minus 4 is 4. Negative 8 minus 4 is negative 12 again. Why did we do negative 4 or minus 4 for each value? Because it's given to be f of x plus 4. So if I need fx, I need to get rid of this plus 4. So I reduced the 4 from these values. Okay, now we have the x and corresponding y values for f of x. And they're asking us for the y coordinate. That means f of x would be of this format. Ax squared plus bx plus c. We need the value of c. Okay, we need the value of c. Now let's head to DESMOS for a quick regression experience. Okay, so this is the DESMOS version used officially by the College Board for the SAT. As you can see here, this is that version, specific version. It's always advisable that you practice on this version itself. I'm providing the link in the description. Okay, so what do? We plot in the points. Begin. Plus in a table, x1, y1, 21, negative 12, 23, 4, and 25, negative 12 again. Now, you don't need to write the regression. Okay, don't need to write the regression expression. Follow my clicks. You write this, then you click here, add regression. Linear or whichever you want, select from here. We want quadratic regression. Regression is done. Just click on this export button and there you have it. Y is equal to so-and-so expression. You don't need to look at the values of A, B, and C or the different regression constants which you take. The equation is right here. They're asking for the y-intercept of this function. That means x is equal to 0. As you put x is equal to 0, you get minus 2112. That's the answer to that grid in question. Okay, so the answer to this question becomes negative 2112. It's that fast. Okay, let's take another one. Okay, this is another hard difficulty question belonging to the advanced math topic. Okay, let's read this. The total distance d in meters traveled by an object moving in a straight line can be modeled by a quadratic function that is defined in terms of t, where t is the time in seconds. At a time of 10 seconds, total distance traveled by the object is 50 meters. At a time of 20 seconds, total distance traveled by the object is 200 meters. If the object was at a distance of 0, when t was 0, then what is the total distance traveled in meters by the object after 30 seconds? Okay, so now they've given us 2 points, but obviously they don't expect us to figure out manually what that quadratic function is. So let's head to DESMOS with what points? 10, 50, 20, 200, and we need to figure out the y coordinate when x is 30. Okay, so let's head to the regression on DESMOS. Okay, begin. So click on the plus icon, table. Okay, x1 is 10, y1 is 50, x2 is 20, y2 is 200. Okay, 20, 200. Is it that? Yep, it is correct. Click on the add regression button. Go to quadratic regression since they've given us that it's a quadratic function. Export the equation. It's here. Okay. And what do we want to find? We want to find the y coordinate when x is equal to 30. X is equal to 30. Right, this line. Okay. Now, one important thing is to adjust the x and y axes. Okay. Let's adjust them. So quickly, you click on this tool icon. Okay. Graph settings. Give the x step as 10. Okay. That'll be more accessible. And the range of x as 100 and negative 20, just for good visibility. On the y-axis, give the y step as 50 because the y values are higher. You see, 50 and 200. And let's say we give an upper bound of 600 theoretically. Okay, and lower bound of, let's say 20. Okay, now you see we adjusted the view and it's right here. You can see the intersection point 30, 450. 450 is the answer. Okay, so 450 is the answer. So what do we learn from here? We learn the exact regression technique, the fastest one on DESMOS. Okay, so definitely just put in the table, put the points, click on the regression button, add regression, okay, and get going. Okay, don't worry about anything. Linear, quadratic, cubic, exponential, all of the ones which you need to use are given here. Just click on export, remove the regression, solve it like a normal question. Solve it as if you were given the equation. Okay, it's that simple. So if you have any confusion, any tip, any difficult question which you have, you think that it's tough to do, we'll try it out. Okay, so we'll meet the next time. Take care. Bye-bye.